Live.
Okay. I've uploaded this to GitHub, but here are two design patterns. One of them is the decorator design pattern. And the decorator design pattern decorates an object in order to add functionality.
Mm-hmm.
I have a very simple example, but I feel like this one's actually really, it explains it pretty well. Talks about decorating your coffee. The original idea came from me. No, I'm just kidding.
Decorating your coffee.
So,
Cream.
you know how you were saying, wait, it's not called an interface. It's actually called a protocol. So you were right. It was a different name. Mm-hmm. Protocols are a little different from interfaces, but they're pretty much the same.
Mm-hmm.
So what you want to do is you want to create a protocol, coffee, and just you have a function get cost and a function get ingredients. You know, pretty basic. Initialize it here, and then you have a class coffee decorator that inherits from the coffee protocol that we got up here. And then you create a coffee let. It's like a coffee object. And then you say, you call the function that you need to, and then you let me see here. So you return a function within this function because you're decorating it. Now this is a very simple part, but if you go down to here where you have class milk, and you want to say, okay, I'm going to call a function within a function, then add this to it. And there's whipped coffee, and you add this to it, and you do an override when you do this. So if you go down here and you have you call it simple coffee, which is the first one that we did, and then you say just get the cost and then get the ingredients, and it will show up here. But then you have it where you do it with the milk decorator, and you do it, and it does coffee, and then it also adds milk to it. And for the whipped cream, for the whipped coffee, it adds whipped to it as well. So it's decorating the functions in order to add, or it adds the functionality to it.
Already existing or ones that you created?
Already existing.
So you're overriding the function to add something else to it. Okay.
And that's the decorator pattern.
Mm-hmm.
See, that's what I was saying. Like some of these things that we've done before, but we didn't know that's what they're named.
Right. So this is all on GitHub. This code here. So if you guys can look at it again, you can.
Is it named coffee? Coffee.
No. And then I have
or Starbucks.
Then I have the not that one. The strategy design pattern. I needed to go over that again because I had it wrong.
That's the one I think, because I told Brother Barney, it's like, oh, well, next I'll be looking into design patterns because that's learn what you've done, Paul.
Yeah.
And he's like, I would suggest doing strategy. I think that's what he said first.
Oh, really? Okay.
And I'm like, can I do proxy? I was like, yeah, sure.
He told me I already did proxy.
Oh, you didn't even know?
I showed him core data. And he was like, okay, and I can also move you up on design patterns. Do you know what design pattern you're using? I'm like, no. He's like, when you go to the temple, and I was like, template? He's like, no. He's like,
oh,
when
proxy.
You stand in for somebody.
Yeah.
You're like vicarious.
Vicarious design.
Okay, so the strategy one I have as well. And this one is the same principle, whereas you create a protocol. And what I'm basically doing here is I'm doing a print strategy. So I'm going to print, but I want to print in a certain way. And this is I can choose at runtime. So I have a print strategy protocol. And then I go down to here and I create another class, say upper class strategy. And there's a class that's lower class strategy. And the point is to print out something that's all upper cases. And the other point is to print out something all lower cases. And so all I do is I have these classes and I have the print string, because that's something that I need to call because of the protocol. And then I do dot uppercase string. And so and then this one for lowercase to do lowercase string. And when I go down here, I just create a var lower, and then I call the printer, and then the strategy will be lowercase strategy, and then you just print it out like this. And you notice how it's both the same here, all the same like caps and everything, or the same cases. But when I run it, hello world for lower and hello world for upper. So the point is to be able to call it at runtime of what you want it to do. With the strategy pattern, it allows you to do that. So it's like you can easily add or extend, add code to it without deleting other code or redoing code. That's just a very simple example of doing it. That's that.
Nice.
So I don't know if you guys need any more for design patterns or not. For
I'm
the-
good.
I think he just said 2 when I was in the interview with him.
Okay. Well then. Two.
I'm gonna sit there real quick so it's easier to show.
It's too close. It's on my bubble.
This is some asynchronous programming. And there's 2 ways that you can do it. This is not Brother Barney's preferred way, but I really like it because it is extremely simple. So basically all I did was create an NS operation queue. And what that is, it's just basically creating another queue for code to run in. And when I click on a certain button, I call this function, which takes the queue, calls add operation with block, and does this stuff on it. So I have it sleep for 5 seconds, gives me console logs. And then after that's done, I call the main queue, which is the queue that the UI runs on, which you have to do if you're going to interact with the user interface. You can call add operation with block on it and change the text of the label saying I slept. So super simple.
Can I tell a funny story about Q?
Go for it.
I was in the MTC waiting in a line to get something, and this, well, I wasn't in a line, sorry. There was a line near me, but I wasn't in a line. This sister missionary comes up and goes, "Excuse me, are you in the queue?" I'm like, "What?" She's like, "A queue. Are you in the queue?" I'm like, "What's a queue?" She's like, "A queue." And I'm like, "Oh, the line?" She's pointing to the line. She's like, "What?" And then her sister missionary, her companion, like grabbed me and said, "We got to go over here." And she's like, "But," she started yelling at her, "but they don't call it a queue."
That was hilarious.
Anyway, I was like standing there, Q. Like I was thinking of the letter Q. Are you in the queue? And I'm like, looking around me. I haven't seen the queue anywhere.
That's hilarious.
Dang,
So-
stinking British.
Pretty simple. It's sleeping. I have this so that I can show that you can user interact with the interface. And then it finished sleeping and it slept.
Oh,
That's really cool.
just to show that it didn't lock up or something.
Yeah, just to show that the user interface doesn't lock up, which if I do this, it will lock up. Oh no, spin wheel of death. Yep. So there it is. Pretty
Nice.
simple. That is NS operation queue, which is extremely simple, as you can tell.
Brother Barney doesn't like that way. Or?
Brother Barney prefers this other way, which is more complex, but is also more flexible. It's basically like, how high level do you want to get? If all you're doing is trying to do asynchronous requests, this is good enough. If you're trying to do a little more, if you want to specify the way that it's done, then you go with Grand Central Dispatch, which is over here.
Some crazy programming.
It's, well, basically what I have it doing right now is essentially the same thing.
Is it almost like the harder way, creating a threading pool? You know
It's
what I mean?
more difficult. It's not near as easy. There's just more stuff that you have to remember.
No one do it your way.
I know, that's how I feel. Brother Barney's like, this is how I do it. Everyone has their preferred way, but this is how I do it because it's more flexible.
So I gotta
Which
say
is
in the
fair.
interview is this is my preferred way of doing it. Okay.
There's a hair.
It's probably my hair.
Chad.
I just like that. I
Okay.
should.
So I've got the queue, and it's a dispatch QT. I don't know exactly what that means, but
Cute.
that's
What's with the question mark.
what. So that makes it an optional, which means I don't have to assign it to.
It could be null,
Anything.
right?
Mhm.
Okay.
Yeah. So that's an optional. It's nil right now, and in here I create a dispatch queue, calling the dispatch queue create. From what I've looked at, this right here is just a bundle identifier, almost like your app identifier. It's just something unique that you can use to call it later. And then there's dispatch queue concurrent, there's dispatch queue serial, and there's one more, which I don't remember what it is, but those are the two main ones that are used. Do y'all know, can y'all understand the difference between that, or do I need to go into that?
I can later. I know
Okay.
there's the difference. I just don't know.
So concurrent allows it to run many things at the same time. Serial means it starts with one and goes to the next. But the difference with using this instead of just doing it on the main queue is it does it in the background. It executes your requests in the background.
Okay.
Does that make sense?
Then with concurrent, what does that do?
It's executing your code in the background, but it's executing it all at the same time. So there's no necessarily any order that it's all going to finish in. It's just going to execute it when it gets to it.
And you'd want to use one for
When it gets to, I thought that was serial.
It's still a queue. It's still a queue, but it.
Oh.
So
That's how I'm confused.
let me draw something here.
Because I know with threading, it'll do it like if you do a loop and you do like make 10 threads, the processor will execute all those different threads at different times. It doesn't go in an order, like 1 through 10.
Right.
It just does it. Oh, I'm going to do this one, this one, this one, this
Right.
one. Right.
Right. Which is kind of how this works. But so this is your queue of tasks that need to be completed, right?
Mhm.
And in a serial queue, it executes this one, waits till it's done, goes to this one, waits till it's done, goes to this one, waits till it's done. This one waits till it's done, this one waits till it's done, and this one waits till it's done. Whereas in a concurrent queue, I don't know how many things it can do at the same time, but it'll take this one, and if it can take another one, it'll take the next one and work on them concurrently. Then it'll take the next one, but maybe that's all it can handle for now until this one. Maybe this one finishes
It'll
first.
still jump back between them, right?
Well,
That's how,
depending on how many cores you have.
oh yeah, that's what
Depending on how many cores you
single.
have. But it'll run them all concurrently. So say this one finishes first, this one ends, and it'll go to the next one. So it's still executing them in a queue order, but it's not going to say which ones finish first.
Meanwhile, serial is like
Serial, this one's going to finish, this one's going to finish, this one's going to finish. Exactly. Whereas in concurrent, these can all run at the same time until you kind of max out.
I'll let you know.
So does that make sense?
Yeah.
Okay.
So you have concurrent, serial, and the third one.
I have no idea.
don't think there's a third one.
There's a third one. I don't remember what it is.
Oh.
Let me see. It's up here somewhere. Oh, main dispatch queue. That's okay. Yeah, whatever. Okay, so you call this dispatch async method, pass in your queue. There's another way that you can do it, calling dispatch queue global or something like that, and then putting in your identifier here. But this is the easier way of doing it, just having it already assigned. And then your block. So I learned something about blocks. Let me show you. Dispatch async. And this was really, because for blocks, I never know quite how to create it, like what to put there, what to put there. Because each one has its own way of doing it. Like some pass in parameters, return different things. So just to enter. Did you see that? And it just created it for me.
Beautiful.
I have to do a thing.
Magic.
I'm sorry, what's a block?
A closure.
Oh, okay.
It's not a closure actually.
It isn't a closure.
It's a block. It's just a block of code to be executed.
Oh, okay.
So it's basically like taking this and putting it into a block of code. It's just you can pass a block of code into a function.
Oh, that's really nice. Okay, I didn't know what that was.
So that was something that was really confusing me for a while, was how to actually create those blocks.
Mm-hmm.
But then I figured out that Swift, the Xcode will do it for you if you just hit enter. The reason I'm getting an error is because if you have this little default code thing here, right, it will yell at you. So I just put a comment in there, put nothing in there. Well, maybe it will still yell. Anyway, so that's dispatch async, and then I have stuff going on in here, the exact same thing essentially. And then I call dispatch async when I'm done, and dispatch get main queue. That's how you get back to the UI. And then that's where I set the label. So one thing to take note, I think I've mentioned this before, but in blocks, you have to reference self before referencing any of your variables that are in the class. I don't know why that is, but they make you reference self first.
Okay.
If you don't, you'll get an error. So that's what I have.
Cool.
Any questions?
No, I mean is that on GitHub?
It's on GitHub.
Cool.
Yeah.
That's nice to know. All right. Chad.
Sequence diagrams. So first, I'm going to show you a simple thing. And this isn't the Brother Barney way, but it's just to understand what the actual things you're drawing are. Does that make sense? And the conceptual process. Because you actually have to write out what the code is. So your class object names, your function names, what they're returning.
Oh.
Pain in the butt. So,
Wow.
all right. I'm getting fat. I have to undo my pants. That's embarrassing.
Yeah.
My wife's like, you need to buy new pants. I'm like, I'm not buying new pants. You kidding me? Too cheap.
That costs money.
They cost you bought an Xbox One. I needed an Xbox One.
I
don't need new
pants.
pants. All right, this is your user. He's not very happy because he has to do this. This is a timeline. Okay, first thing to think is you have to consider is from left to right are your classes or objects. A lot of times you can call a method straight from a class without making instantiate an object, right? Sometimes you make an object and you're calling a method off the object, right? So that's going to be represented by one of these things. So you put a class name in there. I'm going to use their example. Sure, card reader. Right now we're not going to write any classes or objects. But from top to bottom is your timeline in terms of actual chronological order of things that are taking place. So left to right are objects that you're dealing with. Which ones you're dealing with first? top to bottom is the timeline of each one. So you'll when you create it, it'll have like a line, and then let's say you call a method from that class, make a line to it. But for right now, we're not going to actually name the method. We'll just call it, they call it here, insert ATM card. So there's a card reader. So this user is insert card into the card reader, right? ATM. Shink. And then there's a timeline that goes right here. And this can grow depending on if it's getting called somewhere else. So then you continue to another one. It's called the Bank Consortium, which is a verification program, I guess, for the bank. So there's that one. So I'm going to call it the bank verifier because that word's weird. This example has like 4 more over there, but I'm going to stop right there. And oh yeah, this is number 1. And then call over here. Here's another timeline. Okay. And this one is called validate card information. So you inserted the card, right? So now you got to validate that card information. So you're calling bank verifier. Validate. This marker sucks. There we go. You guys probably can't even see any of this.
Yeah, I can see.
Okay, insert card. So validate. And now we got to return information back. Was it validated? And return, when you return something, it's a dot like that. And this would be 1.2. And they call it card validated. All right. And this can keep going down. So like you can create more over here. So they end up making a display, and then they have the card reader calling from the display. They have this user calling way down here, and things are returning. And if so, you see how this timeline on card reader, it talked to the bank verifier and then returned. If card reader didn't call any other functions, or the user didn't interact with the card reader anymore, this timeline ends, this box, right? So this might continue, to something else. And then this might end up calling something else that exists within bank verifier, and then creates another timeline that ends up coming back. Anyway, it can get really confusing, but the main thing to think of is here's my class or object. I'm calling a method off of it. Is the method returning something? Is the method I'm calling does it end up calling another method? So this insert card method needs to validate. So within that function, you got to validate from another class. Mm-hmm. It returns something, and this can keep going. Like this gets really crazy. They created one down here, and the user up down on this timeline ends up calling it from here. And then there's another one right here, and then this is interacting with this, and then it's returning something. Anyway.
That's gross. Wait, so how is this helpful?
How is this helpful? Apparently it helps you, this is like the last stage after state diagram and preparing how you're going to write code. It helps you keep it organized of thinking of how you're going to write code. So now I'm going to do a code example. This is like a conceptual thing.
Yeah.
It's like, oh, I'm inserting a card. It's validating. So let me do a little bit of code.
That was the application level?
That was more of a conceptual overall, like if you were looking outside of the program, that's what I just did is what the user sees, right?
Right.
When the user's doing it, he doesn't know the name of the function that's doing it.
Right.
So instead you said I put insert card, I actually have to write the method name there. This is how Brother Barney wants it. The way I just did it is another way to do it. But Brother Barney. Oh, I love you, Brother Barney.
You
I hope
can
you
cut
don't
that
show,
part.
I hope you don't show that part. Function, yeah, function name. So real quick, I'll do another one. Almost 10, okay, I mean 11.
Do you have to leave at 11?
No, just, I don't know, maybe it's gotta go. So this is kind of simple. But with this example, they don't have a user interacting with it. Imagine the user's interacting with something that's then interacting with this. So, because right now I'm just concerned with how to explain. So this is an analyst of the class financial analyst, and this is how you write it. So analyst is your object of the class financial analyst. Then we have another one, system reporting system. And this, remember in the state diagram, I said, oh, you got to make all your states first. You don't want to make all your timelines first. You want to like create them from left to right. So what is the user interacting with? Okay, I'm going to move down this line here. Okay, is this at this point, is it interacting with anything else? Okay, we got to create another timeline. And that's how you work. You kind of feel like working like that.
Okay.
Financial analyst, system. So this is an object, and then you put a colon and you put the name of the class. All right. All right, so the name of this method is get available reports. So it goes over here. I spell available. Available.
Yeah, switched
Okay.
it.
Huh?
It's an AVAI.
Yeah.
Able.
There we go. Get available. Okay, imagine there's a reports on the end of that method. You would even write in what parameters you're passing. But right here it's a get, so we don't have to pass any parameters. Oh, I need to get that caffeine thing. Huh.
Uh-huh.
Where'd you get it? Where'd you get
It's
it?
the App Store.
App Store?
It's on
Okay.
the App Store.
And we're returning an object. Available reports. Bull reports. And you have a box right here, like that, okay? That represents the existence of this object downwards. Anyway, can you see how this sequence diagram can be tough?
Yeah.
Looks like.
You have any other questions?
Do you have a full, or can you send us a full blood example? Like, where do you see those examples?
The first one is a visual paradigm. Visual paradigm. It's called 5 Steps to Draw a Sequence Diagram, but they don't actually put any code in there. And I went online and found a bunch of different examples. I was trying to think of some good ones. And on IBM, their examples use actual code. So if you Google it, just try and look for ones that actually have code.
Okay, Stigner.
And that's the one that Brother Barney wants. But if you want to understand the overall concept, the good one is by Visual Paradigm. They have a tutorial. It's like 5 steps to draw a sequence diagram, which are some confusing 5 steps. So that's why I didn't say you guys should follow these 5 steps, because it just confused me.
Okay.
Another thing is, if it's a continuous thing, you remember me numbering it? So it went 1, 1.1, 1.2, 1.3, because it's like a cause-effect relationship. It's like a chain. Oh, this causes this, this, this. If it's something that's totally starts anew, like another kind of sequence.
It's like the user
Sequence
hits another
diagram, right?
button or something.
If you look at that, it puts it 2.1. See that?
Input password. That makes sense. Verified password verified. Show me.
You notice how some of them, so do you see right here how it goes to here and then it comes back, but it's a solid line? Because that isn't a return. Like this display has, in a sense, it's another like function that's happening or method.
Basically a void.
Called.
Yeah, it's like a void or
Whereas card validated probably return like a Boolean or something.
Uh-huh.
That makes sense. Password verified.
So yeah, the little dotted lines it's actually returning something. And these are actually objects, or if you're calling a method that's just straight from the class, you would write it like this.
Okay.
Oh, so like a static method.
Yeah. Mm-hmm.
Okay.
It's tough stuff.
So I talked to Brother Barney actually about it last time, and he said, worry about those after Thanksgiving. He was like, what we're going to do before Thanksgiving is just get everything else, all the code stuff, up to here. He was like, because that stuff will come when you